Hello and welcome to this R tutorial. So that's it, we did the big first step of natural language processing, which consisted of cleaning the text we're working with, and now it's time to create the sparse matrix of features containing all the different reviews in the rows and all the different words of the reviews in the columns. So as a reminder, what we're about to build is a huge table in which the rows are the 1000 reviews, so we're going to have one row for each review, so we're going to have 1000 rows, and then the columns are going to contain all the words we can find in the 1000 reviews in this corpus, that is the 1000 cleaned reviews. And so basically what this means is that we are going to take all the different words in the 1000 cleaned reviews in the corpus, and we're going to create one column for each word. So suppose we count in total 1500 words in this corpus of reviews. Well, that means that our huge table is going to contain 1500 columns. And then for each cell in this huge table, well then each cell will correspond to one review corresponding to the row and one word corresponding to the column, and so the value that will contain this cell is the number of times the word appears in the review. So as we explained earlier, since most of the words don't appear in the reviews, well, most of the cells will contain a 0. And then of course we'll get a few ones because each review is composed between 5 to 10 words. So in each row we're going to have 5 or 10 cells having a 1 and all the other cells will have a 0. And the cells that have a 1 will be in the columns corresponding to the words that are in the review. And maybe sometimes, but very rarely, we'll get a 2 or a 3. That happens when the word appears twice or 3 times in a review. I can give you a simple example. Let's imagine that we have a super positive review saying, I love this restaurant very, very much. Well, in this review, the word very appears twice. So for this particular review in the table, that is, let's say it's the row 100, well, in the cell that belongs to this row and that belongs to the column corresponding to the word very, well, we'll get a 2 because very appears twice in this review. So that could happen, but it's very rare, and what's most important to understand is that in this huge table we'll get mostly zeros, a few ones, and a very few 2s or 3s. And we'll get so many zeros that we call this table a sparse matrix. A sparse matrix is a table that contains a lot of zeros. It contains very few non-zero values, and that's exactly what we're about to obtain because of what we've just explained. And you'll see in the information of the table we build that we have the word sparsity, and sparsity refers to that situation where we have a lot of zeros. And speaking of sparsity, let's also keep in mind that if we cleaned all the reviews here in this first step of natural language processing, it's in order to reduce as much as possible this future sparsity that will occur in this huge table that we're about to build. So that's the whole point behind this first step here, cleaning the text. It's to avoid having too much sparsity, that is, it's to avoid having a table too big with too many columns, because remember, one column is created for each word in the corpus. So by doing all these steps here, we removed a lot of words and a lot of characters, punctuations, numbers, etc., so that in this final huge table, we get the minimum number of words and therefore the minimum number of columns. And one last quick reminder, we are creating this table in order to have the framework of classification models. That is, having several independent variables and one dependent variable. We haven't created the dependent variable yet. It's actually in this data set here. We will just take the second column of this data set because this contains the outcome, whether the review is positive or negative. We can see that here. It's the second column liked. 1 if the review is positive and 0 if the review is negative. So that's the dependent variable column, and the independent variables are going to be nothing else than these columns corresponding to each one of the words in the cleaned reviews of the corpus, because for each review, that is each observation, we can link the review to each of the columns, because for each of the review we can associate a value for each of the columns, and this value is the number of times the word corresponding to the column appears in the review. So that's how we create our independent variables, and then we'll create our dependent variable, and therefore we'll get the classification model as we used to work with, and eventually we win because we will have everything. We will have our independent variables, we will have our dependent variable, and we already have all our classification models. That's the models we made in part 3. So we will just need to apply these models on our new dataset that we're about to create that contains the independent variables as the words and the dependent variable as the liked column in our original dataset. Alright, so let's do it. Let's create this table. And in R, we can do it very efficiently using a function that is called document term matrix. And it's super easy because this function will only take one argument. And as you might have guessed, it's going to be the corpus. And that's it. This will create this huge sparse matrix with all the 1000 reviews in the rows and with all the words of the reviews in the columns. So let's do it. Let's call this sparse matrix of features DTM because the function we're about to use is document term matrix. So far we'll call it DTM. So equals, and then we use this super function document term matrix. Here it is. I just need to press enter. And as I just said, we just need to input one argument, which is our corpus. All right, and that's done. Here it is, corpus. This will create our sparse matrix of features. So I'm going to select this line and execute, and done. The sparse matrix of features is created. It appears right here, DTM. We can click on this button here to have some info. And actually what's interesting to see now is the total number of words counted in the corpus to create all the columns. And we can see this total count here, 1577. So that means that the number of columns indicated by encol here in our document term matrix, our sparse matrix, is 1577. So that means that this huge table has 1000 rows. So we expected this because of course we have 1000 reviews, but we didn't expect the number of columns in total because simply that was the total number of words in the reviews, so we couldn't count them. But we can see this number here, 1577. So that's already a big table, but be prepared if you're working with more complicated text or longer text like articles or books. Well, you might get a lot more columns here because you will get a lot more words. So what you'll have to do, and you can ask me any questions about that in the Q&A, is reduce even more the sparsity by filtering the words in your text. And speaking of filtering, that's what we're going to do right now. We are going to apply a filter to clean even more the reviews by only considering the most frequent words. That means that it's like we're going to add a step in this text cleaning process, which will consist of only taking the words that are the most frequent. For example, the words that appear in only one review, well, they might be removed because they're not frequent. They only appear once. Only one cell in the matrix contains a 1 because this word only appears in one review. And these words, of course, are not very relevant because since they only appear in one review, well, our machine learning classification model will not be able to establish any correlation between this word and the outcome, whether the review is positive or negative. Because indeed, to understand such correlations, the word would need to appear in at least 2 reviews. So that's the kind of words we're going to remove. And again, this is in order to reduce sparsity. And speaking of sparsity, I will show you something very interesting right now. If we go to the console and type here DTM, then we'll get other information about this sparse matrix of features. And the information that I want to highlight here is, of course, this sparsity information. And as you can see, the sparsity is 100% right now. And that's because there are a lot of zeros in the matrix, and also because we haven't filtered any non-frequent word yet. So that's what we'll do right now. We will filter all the words that appear only once. We will filter all the words that are not frequent in the reviews. All right, so let's do it. To do this, we are going to update our document term matrix. So we're taking again DTM here, all right, because we're updating our sparse matrix, and equals. And now we're going to use a function, a very practical function, that will filter the non-frequent words of our sparse matrix, which so far is nothing else than DTM. So DTM will be one of the inputs, and we will filter all the non-frequent words by specifying a proportion of non-frequent words that we want to remove from the sparse matrix. And this proportion of non-frequent words will be obtained thanks to the second input of this function, because the second input is the percentage of the most frequent words we want to keep in the reviews. So let's say we want to keep 99% of the words in the review that are the most frequent words. Well, this second input will take the value of 99%. So let's use this function. This function is remove sparse terms. Here it is, remove sparse terms. So pressing enter and ready to input the two arguments. So the first argument is, of course, the sparse matrix on which we want to apply this filtering. So of course it's DTM. All right. And the second input is the proportion of words that are the most frequent words and that will be kept in this sparse matrix. So let's say we want to keep 99% of the most frequent words. Well, we would need to input here 0.99. And therefore we will build the same sparse matrix, but this time containing 99% of the words that are the most frequent in this sparse matrix of features. And therefore, we're not looking at the corpus containing all the words and counting the most frequent words of this corpus. What this function remove sparse terms will do is to look at all the columns of this sparse matrix here and then keep 99% of the columns that have the most ones in the columns, because each column corresponds to a word, and therefore when there are very few ones in the columns, that means that this word appears in very few reviews, and therefore these are the words that are non-frequent in the reviews and accordingly not relevant. And that's why we can remove them. Alright, so let's do it. Let's apply the filter. To be cautious, let's maybe take a higher proportion of frequent words we keep, because actually with 99% we might remove a lot of words. You can try it on your RStudio to see. But here, since we don't have many reviews, we have 1,000 reviews, that is not much compared to other texts we can work with in natural language processing. Let's be careful here and apply a 99.9% proportion of frequent words. So here I'm going to add a 9, and you'll see that it will already remove quite a lot of words. So let's try it. I'm going to select this and execute. And indeed, as you can see, we now have 691 columns in the sparse matrix. That is, we only kept 691 words. So clearly we can see that by keeping 99.9% of the words that are the most frequent, well, that already removes almost 1,000 words. Because originally we had, remember, more than 1,500 words. So be careful with this. Be careful not to apply a too low proportion of frequent words you want to keep. And to choose that, remember to look at the total number of words that is counted when you build this first sparse matrix. And of course, you can also choose this number by considering the total number of reviews you have in your original data set. And since we only had 1,000 reviews, well, that's why we take such a high proportion here. And let's see by how much we reduce the sparsity. So we have to type DTM again because our document sparse matrix, that is our sparse matrix, was just updated with all these words removed. So pressing enter here, and the sparsity now became 99%. So better, but anyway, that was fine because we didn't have too much columns. You will see that if you work with larger text, you will get a lot more words and therefore a lot more columns. Alright, so that will be all for this tutorial. We built our bag of words model, congratulations for that. And now it's time to make the classification model. So that's what we'll do in the next and final tutorial of this section. And until